Okay, let's see what the solution then to part A is. Now, first of all, this question is basically on what we call transformations of graphs. It relies on the fact that you most probably have a good understanding of basic graphs, and in this case we're looking at the graph of y equals 1 upon x, or f of x equals 1 upon x. Let's just put a y-axis there, and so what we're going to do is first of all sketch the graph in of f of x equals 1 upon x. Now, as I say, this is a graph that you should be familiar with, and hopefully you know that it looks something like this. Okay, going down like there and coming round like so, like that. Okay. Now what we've got to do next is plot the graph of y equals f of x plus 3. In other words, this graph, f of x plus 3, is really the graph of 1 over x, that's f of x, then plus 3. Okay? Now I mentioned transformations of graphs earlier because we take f of x, and when we add a number outside the function, the effect that it has on the original graph, this one here in red, is that it will translate it upwards by 3 units, parallel to the y-axis. Okay? If this said minus 3, it would drop the graph down 3 units. Okay, so I'm going to take the graph that we drew, and I'm going to attempt to translate it, say 3 units up. So imagine that there it goes, 1, say 2, 3 units upwards. We'll pretend then that that is 3, and so we would get the graph moved to that position. So that would be the graph of y equals fx plus 3. And it's quite often a good idea in sketches like this to show what is often called the asymptote. And the asymptote before was the x-axis, that is, the graph approached the x-axis. Leaving the graph like this is not what I call anyway particularly good, so what we're going to do is we're going to put an asymptote in, and I'll do that in a black dotted line. That'd be a line that runs through here. The graph approaches this line, and that line is the line y equals 3. So it'd be a good idea just to put a 3 there, say, to show that the graph is approaching y equals 3. Okay? In fact, the question says, state the equations of the asymptotes. So those asymptotes are y equals 3 and also the y-axis, and its equation is x equals 0. So what I'll do here is I'll just write in then that the asymptotes, okay, are y equals 3 and x equals 0. X equals 0 being the y-axis. Okay. Now in part B, we're asked to find where this particular graph crosses a coordinate axis. And it's clear from the sketch that the only point that it's going to cross an axis is this point here. So where does a graph cross the x-axis? It is when the y value is equal to 0. So it crosses the x-axis, so I'll tell you what, we'll just put this in here, crosses the x-axis when y equals 0. So therefore what I get is 0 equals 1 over x plus 3. So I'll just put that in, 1 over x plus 3. I could do several things here at this stage. I could take 3 from both sides, or I could multiply through both sides by x. I'm going to opt for removing the value x, so I'm going to multiply both sides by x. So therefore what I get is 0 times x, which is 0, equals 1 over x times x is 1, and then 3 times x is 3x. Okay, let's just scroll up a little bit. Therefore, next thing I'm going to do is subtract 1 from both sides, so I get minus 1 equals 3x. Next I'm going to divide both sides by 3, and that will leave me with minus a third would equal x. So I'm just going to turn it round and say x equals negative 1/3, minus a third. It asks us to find the coordinates to the point where it crosses the coordinate axis, so I'm going to finish up with saying that therefore, what should we say, graph crosses the x-axis at minus a third 0. Okay, so let's just put here crosses x-axis at minus a third 0. Okay, so that point there, just looking at it, looks reasonable. Always check your answer. You never know, you might make a mistake here, get say a third or something like that. Clearly this is a negative value, so got a chance of being right. Okay, so that's it. So I hope you got that one right.